In this video, we're going to talk about some applications of exponential growth and decay and some compound interest problems as well. So your formula for exponential growth is going to be f of t equals a times 1 plus r to the t power, where a is your initial amount, you can't write amount apparently. R is your growth rate, and t is going to be your time. So let's do an example. The original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So before we do f of 15, because that's 15 years, let's figure out what f of t is. So f of t, our initial amount is $1,800. And then 1 plus our growth rate, which is 7%. So 7% equals 0.7. So 1.07 to the t. So then we're going to just plug that in. We're going to plug in 15 for t. So 1,800 times 1.07 to the 15. So that's $4,966.26. So that's the value of the investment after 15 years. So then 2 is for you to do. Exponential decay is a very similar formula, except instead of a plus r, it's a minus r. Apparently Siri wanted to talk to you today. So A is the initial amount. R is your decay rate, so your growth rate, and T is still time. So an investment of $12,000 is losing value at a rate of 4% each year, so 4% is 0.004. Write an exponential function to model the situation and then find the value of the investment after 9 years. So we're going to want to find f of 9, but before we find f of 9, let's find f of t. So 12,000 is your initial amount. 1 minus 0.04 is 0.96, and then raise it to the t. So 12,000 times 0.96 to the 9 gives you 8310 point. Let's write that so you can read it. 8310.41. So that's how many dollars of the how much money of the investment would be left if you're losing a value at a rate of 4%. So 4 is for you to do. And then compound interest. You may have talked about this already in personal finance. So formula A equals P times 1 plus R over N to the N times T. P is your principal. Or your initial amount. R is your rate. N is the number of times compounded yearly or annually. and then t is your time. All right, so quarterly, let's read it. Laura deposited $12,000 into an account that it earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So quarterly means 4 times, so n equals 4. A equals $12,000 times 1 plus 8% interest is 0.08 over 4 to the 4.5. No, 4 times 5. Sorry. Because 5 years and 4 is how. So if you simplify this, you get 12,000 times 1.02 to the 20, which gives you about $17,000, $17,831.37. We'll do one more and I'll leave the other two for you to do. So Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5 interest rate. If the interest is compounded monthly, so that means 12, what will he have paid over the course of the loan? So A equals $25,000. 1 plus 0.045, because that's 4.5% in decimal form, divided by 12 to the 12 times 6, because it's a 6-year loan. So then I get $25,000 times 1.00375 to the 72 power. So then that gives me 32,732 and 58 cents. So that's how much money he would pay if he actually did this. So that's compound interest and exponential growth and decay application problems.